Hello everyone, this is the video lecture for Business Calculus, Math 1325. We're in 10.5 right now. So I haven't done videos now in a couple weeks. I know that this is all not relevant to you because you're going to have all the videos at the very beginning of the class. That's how I roll. But I actually went through and finished all of the coursework, all the homework, and all the lecture stuff here just today, actually. So I already went through the entire class, and I know what to expect now, and it's challenging at some times, not really difficult to finish. It's just some of the questions are not very fun, and that's okay. You and I are in this together, and that's okay. That's just how life is. Life is not always fun, right? And y'all are in business. You're going to be doing business thingies that are not always fun, but that's fine because you're going to make money, and you'll make more money than me. Ha ha. So, I'm here honestly, unless you want to be a teacher. So this one is actually a really fun section. There are a couple annoying pieces here and there, but I really love implicit, and it's such a cool concept. I take it to the next level, probably too much because you're going to not have to go that far here. So with all that, let's talk about it. So what we're doing is we're taking a derivative, and what I call it is that we're going to flag it. So let's just do a really quick example of what implicit looks like. So we got y is equal to x squared. It says take the derivative of this stuff, like go to the next level, take some derivatives, implicit differentiation, da da da. Well, it's y prime is equal to 2x. Yay! We did it! I'm serious. That's all it is. We've done this before. But I'm going to show you my flagging method so you can kind of understand a little bit deeper, because it is sometimes important to understand what they're asking for, because they'll have weird Leibniz notation. This is Newtonian. The Leibniz notation is a little weird. So instead, what Chad's going to do is I'm going to say, oh, we have a y. Well, I'm going to take the derivative of that y. You see, this y went to dy, okay? You can almost think of it like there's a 1 in the front. So 1y now is 1 dy. This is the flag part of it. It's like a little flag saying, hey, I took the derivative of y here. That 1 is still there. For this guy, it's 2x. Sweet. But times dx, and again, that's kind of like my little flag saying, hey, I just took a derivative with x. So these are indicating stuff. So we got dy is equal to 2x dx. This is the more Leibniz classical understanding. And so what you do is you move the dx over. So dy dx is equal to 2x. Well, we already had that a long time ago. This is basically just y prime. So there is a need to know the notation a little bit, but most of the homework is just going to say, stick a prime on it. And that is okay. That is okay. So how about this? You remind me, as I go, you remind me if I go off the deep end. Stop the video and tell me. Okay. So the very first problem, and I think this is problem number 1, if it's not, it's very early on, is 7 parts. Ugh. Oh, I'm not laughing at you, truly, because I'm the one having to do it now twice. You only have to do it one time. I did it on my paper, and now I'm doing it in front of you here. So the joke's on me. So here we go. D dx of 8x cubed is equal to what? And like there's a whole bunch of parts, a through whatever. So I'm just going through them. So what do we do here? Is they're trying to say what's the derivative of this little piece. It's very simple. You move the 3 down, you get 24x squared. Ding, ding, ding. Yep, and that was it. So the next part says, what's the... Oh, they don't even have the minus sign. They just have this part. Say, what's the derivative of this thing? Well, how many x's you got? None. 0. Boom! No. They don't like that. It's 7y prime. And just like what we did up here, when you're taking the derivative of y, you get y prime. Okay? That's what they're doing right here. So I had a y, now it's a y prime. There was a 7 in the front, now there's a 7 in the front still. So there's your answer for that one. And they're going to keep going down the list. They say, what's the derivative of 9? It's obviously a 0. And it says, what's the derivative of 0? I love that. It's 0. Yay. And then it says, find y prime. Okay. So to do this, I'm basically just going back up to the top and plugging each one of these in individually. That's what they're trying to say. So I had the 8, x cubed minus 7y minus 9 equals 0. Well, implicit now would be the 24x squared 7y prime 0 equals 0. Yep, my Wi-Fi is going out a little bit. My name is Burrow, so there you go, Professor Burrow. And I'm at home. You might see that a couple times. I'm so sorry. Oh boy. I'm not going to edit that out. Am I? I don't know. I didn't give you any passwords, so I guess it's not too bad. You set them. You put this move to this other side. You divide both sides by 7, and there you go. 24 divided by 7. Isn't that like a number? There is 21. Yeah. I'm just verifying. Just verifying, okay? Ta-da! We did it. Sweet. So we did y prime. That's y prime there. The next part, it says... What does it say? Oh, just find y. They just say find y. Okay, from like the original. Okay. Well, I guess I'm going to move this over. And then divide by the 7. So there you go. Yeah, that's what they want. Hooray! We did it. Okay. And they say, hey, now that you know this, what's y prime equal to? Are you joking, bro? It's right there. They want you to do it again. I just copy paste, honestly. Copy paste. And I have a note at the end here. It says, so what was that? They're saying that integration can go different ways. And they're trying to show you like a hand-holdy method. I don't need the questions to hold your hands, guys. I'm here to hold your hand. And it's like not slimy because I've just washed my hands. So it's okay. You can hold my hand. Did that sound creepy? Anyways, you ever hold like a little kid's hand and you're like, man, why is that sticky? Ew. Yeah, exactly. I have little kids and you never know. So moving on. Hey, that's on math YouTube videos right there. So real world experience. So they're saying find y prime. This is fun. I love these kind of questions. They're cool. So I'm gonna do it with the y prime thing. I'm not gonna flag it until we actually need to. So I'm just gonna go normal derivative prime-y stuff. Okay. So the 2 comes down. You make it 12x. Here, the derivative would be 2y, and you're done. But again, with the flags, you would put like dy and keep doing the stuff. But with the, I guess you would call it Newtonian style, you just say, hey, y prime. Okay, so whenever you take a derivative with y, just say y prime. If you want to call that a flag, that's fine. I don't know. My little flags are always from France or something. I don't know. So minus 0 equals 0. I want to get y prime by itself. So what I'm going to do is move this whole chunk over. And then I'm going to divide by the 2y on both sides. And there's my answer. I can simplify, obviously. Something like that would be fine. Cool. Is that what I got? Yeah, that's what I got. Then they say find it at 3, 7. So this is your x, this is your y. You're going to plug them in, and here we go. So y prime at 3, 7 is equal to 6 times 3 divided by 7. 18 over 7, because you're going to do these guys here. Ta-da! We did it. That was it. Next question. Okay. Negative 8e to the y is equal to x cubed plus y cubed. And they want the same thing. So I hope that you're discovering that, yes, I'm not doing every single homework question. That would actually be counterproductive in the end. But I do not skimp on them. I am doing at least 50%. And even then, I'm trying to do some hard ones that like stand out, like, ooh, how do I do that, you know? Now, they're all easy to do. I just want to make sure that I cover them so that you're seeing what to do in these weird cases. So like this e thing. What's the derivative of e to the x is e to the x. So it doesn't change when I take my derivative. Like this is my derivative line right here. But again, I took my derivative with y, so you got to do a y prime there. We got 3x squared, and then we got a 3y squared. Y prime, exactly. I was waiting for you to say it, okay? I was waiting for you to say it. Okay, so I'm going to move this over, and I'm going to move that over. So I got 3x squared, is negative now, is equal to 8e to the y prime plus 3y squared y prime. What do they have in common? Is a y prime. Very good. So I could just stick a y prime right there. Divide to the other side. And there you go. Is that what I got? That's what I got. And again, when I always check these on the homework, I don't just look at it and say, it's probably fine. I do that in algebra, but I don't do it here because you'll see in just a second with the next one why I don't do that, okay? I do double check them to make sure that I actually, that my math lab does what it wants and all that stuff, okay? You get what you need. So this is your x, this is your y. I'm plugging them in. I got negative 3 times the negative 2 squared. 8 times e to the 0 plus 3 times 0 squared. So that goes away. This is a 1, so this part goes away but leaves the 8. So I only got an 8 in the bottom. Here we got a 4, so negative 3 times 4 divided by 8. That's going to just leave a 2 in the bottom, negative 3 halves, and you're done. Okay, so the next problem is annoying, and I actually wrote that in my notes. I said... that was annoying. It looks like this. That was annoying. I have that written in my notes, just like that. And I have to say, again, because it's been a couple weeks since I've done this math, I'm like looking at it before I actually start, like review, I guess you can say. But at the same time, I have not done this problem in a couple weeks now. And so I feel like I'm a little like disconnected. Why did I say that was annoying? And I'm gonna show you why here in a second. So it's very similar to the last ones. I want to say what's my y prime, and we're gonna plug that in. Okay, so that's a plug it in kind of situation. But before we even get started, it's not enough. You see, I need a y equals to make it work. I only have the x value. So what I'm gonna do is plug this in right here. And we're going to get our y's. Now, to better do this, I'm not taking a derivative yet. To better do this, I'm going to actually just solve for y. So what I'm going to do is move this over. So I got y minus 3 squared is equal to 4 minus x minus 5 squared. I'm going to square root both sides. And if you remember how this works, square rooting both sides means that you have to have a plus and minus. Add 3, and again, make sure that 3 is like on the outside of the square root. Okay, so this is a pretty important piece of information. Because what we're going to do is we're going to plug in that x equals 6.6, and we're going to get two different answers, see, because the plus and minus. I'll show you in Desmo Scientific, just that you kind of like say, oh, yeah, you think that I'm actually being honest, which I think I am. So there's one of them, and then the other one's having a minus in the front. Now, it's not like minusing everything. It's just minusing the square root, okay? So these are your two y values. I can confirm that's what I got as well. So 4.2, and I got 1.8. So these are my y values, okay? In a way, I have to plug them both in with the x here in just a second. Now, like, I haven't even done any derivatives. I haven't even done the calculus at all. So in a way, we haven't technically started the problem. That's not why this was annoying. I'll show you why, okay? This is classic. This is classic MyMathLab here. Okay, so they say find the derivative of this thing. And we're going to plug these things in. Again, we already know that x equals 6.6 for like both of those. All right, so here we go. The 2 comes down. You leave the inside alone. Now it's a 1 power. Derivative inside's a 1. It doesn't really matter. So I don't even have to write those ones. The 2 comes down. Leave the inside alone. 1 power, take derivative inside is nothing. But wait, there is a y prime. Because I took the derivative with y, I got to have a y prime there. And this is 0. Move this over, and I'm going to take this and divide that to the other side, like all at once. I hope you're okay with that. I'm like doing 2 steps at once because I get a little lazy. Now the 2's can cancel, and you can actually take this minus and distribute it. So what it does is it flips these numbers, or you could just say negative x and plus 5. That's fine. Either way is fine. So this is like our answer, but not really. That's not what they want. So we got this, and then we're going to plug in my x's and y's. So x is equal to 6.6, and y is equal to 1.8 is one of them, and then x is equal to 6.6, and then y is equal to the 4.2. So these are my 2 points that I'll be plugging into this to get my y primes. So let me just make sure I'm doing this right. That's a 5. Yeah. So I got 5 minus the 6.6 over 1.8 minus 3. 5 minus the 6.6. 4.2 minus 3. Okay. Here we go. 5 minus 6.6. 1.8 minus 3. Oh, okay. That's nice. And then 5 minus 6.6, 4.2 minus the 3. Awesome. Yep. So negative 4/3. No, this is a positive one. And this is a negative 4/3 here. So we got the same answers. Negative and positive. Those are the 2 answers. Cool. We're done. What? Why are they wrong, Chad? They just wanted a decimal. Oh, that is so annoying. And yeah, maybe it says find a decimal. Maybe it doesn't. I can't remember at this point. But the exact answer is right in front of you. So why won't you accept an exact answer, MyMathLab? I don't know. I find it annoying. Okay. Next one. Moving on. So we got y squared minus x times y plus 12 is equal to 0, and x is equal to 8. So it says find the y values. Ooh. For that. And so I'm going to do like an arrow thingy. Y equals, and we got a box. And then it says find the tangent line at these points. So we're going to get to the tangent line in a second. This one's a little bit longer problem. That's fine. So 8 is x is 8. So I basically just make an 8 right there. And then they say, go ahead and solve. Well, this is a quadratic, and you can factor it. And so what 2 numbers multiply to 12 but add, finger quotes, add to 8? So this is 4 times 3. But it's also 6 times 2. And see how 6 and 2 would make it 8? So negative 6, negative 2. And so if you solve, just switch the signs. And those are the answers that they want right now. So you put them both in there. Awesome. Part B, it says find the tangent line at 8, 2. So 8, because x is 8, and 2 because y equals 2 right there. And they're going to use the 8, 6 here in just a second as well. So to find a tangent line, what they're saying is y minus y1 is equal to m, x minus x1. This is our equation for a line. Well, this slope right here is the same as saying y prime. So what I'm going to do is find y prime and like plug it in right there. And then you just plug in your x and your y and boom, you're done. And that's the idea. So it shouldn't be too bad. Let's go back to the original and we're going to start finding y prime. So this is what I got. And they say find y prime. All right, so 2y, y prime, again, because derivative of y, you put a little prime thing there. This is actually product rule. You got two different things. And so here we go. I got derivative of the first, leave the second alone, leave the first alone, derivative of the second. Now, derivative of a y would be a y prime, but derivative of x is just a 1. Again, this is not the normal style that I use in my other calculus classes. I do the whole dx flagging thing a lot more, especially in Calculus 3. It's very important. But here in business calculus, we see it, we move on. So this is efficient, it's clean, this is what you do, okay? So you're saying, hey, what do I do, Chad? You do this, okay? We have to distribute this minus. So it looks kind of like this. And I want to get my y primes by themselves. So I'm going to move this over. And then I'm going to move this out here. They both have a y prime, so I can just factor that out to the front. Divide. So we get y divided by 2y minus x. Again, this is my slope. This is my m. So what I need to do for each point, and this point in particular here is 8, 2. I need to plug them in here. So my y prime, my m, would be 2. 2 times 2 minus 8. So 4 minus 8, negative 4. So I got it negative 1/2. Okay. So here we go. There we go. Y minus y1, m, x minus x1. We're going to plug them all in. My y is a 2. My slope is a negative 1/2. And my x is an 8. Again, it's right here. X, y, slope. Okay. Sweet. Yeah, I do have to keep going. Okay. So, darn. And this is only like one of the problems. We got the other half here to do in a second. Half of 8 is 4. I'm going to add 2. Sweet. Like, there's so much more that's going on here that I just don't think we're going to have the time to talk about. But I really like the math. I just sometimes feel like it's just such a rush in this class to get everything done. And we just don't got time for that. Anyways, repeat for this. Thankfully, we don't have to redo the y prime formula. We already have it. So all that is taken care of right here. So that's y, 2y minus x. Yeah, I'm just verifying. So 6, 2 times 6 minus 8. 12 minus 8 is a 4. So what, 3/2? Yeah, I think so. Yeah, that's what I got. So this is my slope. Y minus y1, m, x minus x1. Okay. Distribute. Half of 8 is 4. 4 times 3 is 12. It's a minus. So that would be a negative 6. That's what I got. Cool. And I think that they want the y equals inside the box, that you have to type that as well. That's how I have it formatted here. And I usually try to keep it exactly what they're wanting in my math lab, like what worked. And it worked like that, okay? The next one is different. And that's why I'm doing it. I mean, I wouldn't do the same thing a lot, you know? But the last one, I don't even know why I did it, honestly. I'll show you why here in a second. I mean, I'll show you why I felt like I had to do it. But I honestly don't think I should have, but whatever. The more the better, honestly, that I can do for you. But with you, not for you, with you. The more I can do with you is better, to a degree. So find y prime, and then plug in the 1, 1, and all that stuff. So it's just the same as always. This one looks kooky. You know what I mean? Not cookie, kooky. Not like a chocolate chip cookie. That Chad, that's a pizza. I don't even know how to spell it. What do we even do here? So I have to take derivative of this. So the 5 stays in the front. Derivative of ln is 1 over stuff, and we are done there. Except that we're not, because we have to take the derivative of the inside. That's that chain rule stuff, which you totally know now. Notice that here it's 2 different things, right? So take the derivative of the first, leave the second alone, leave the first alone, derivative of the second. It's that whole f prime g plus fg prime product rule stuff. All of that came from right here, equals. And then right here we got 2y, y prime. The 1 goes to a 0, so we don't really care. I need to get y prime by itself. That means like right here. So first I need to actually like distribute, which is not fun. What I think I'm going to do instead is I'm going to take this and I'm going to multiply it to the other side. And then I think I'm going to distribute this 5. So the 5 is going to go here. This thing is going to go here in the numerator. So just hang out with me, okay? Hang out for a second. Something like that, okay? The 5, again, gets to both of these guys. This one here was in the denominator. Now he's going to be over here in the numerator, okay? So I want my y primes on one side. I'm going to move this over. And I know this is just looking really crazy, but here we go. 2, and then there's an x. There's a y squared, and then there's a y prime. And then minus 5xy prime. They both have a y prime. I can factor that out. Surely you do this sort of thing for fun on the weekends, right? Chad, it's definitely on the weekends. ... Don't finish that sentence. You know what, guys? Pause. I don't have that answer. I mean, I think it's right. If you give me just a second here, let me just look it over a little bit. Yeah. Yeah, they're equivalent. Try that. What I have written down is this thing. So I just went a different road. For sure, this will work. This is definitely, I know this will work. My math app will probably make this work, so I'm going to put like a little squiggly check because this is better looking than that thing anyways. So I think we did better here. What I did is I probably just distributed the whole thing right here, and then I started to do its thing. I don't know, just whatever. Moving on. This is great. This is great. Let's just use what we have, okay? Because it's easier. And then they say plug in this 1, 1. So both x and y are 1. So plugging it in. Yeah, I like this one better because you don't want like a little fraction inside of a fraction. That would be just silly, right? Nobody wants that. -3, -5 over 3. Is that what I got? Yeah, that's what I got. Cool. Now, again, that's a negative in the bottom. I'm just going to remind you, negatives can go in the top, bottom, middle, front, back, whatever. It doesn't matter. As long as it's like the whole thing is negative, essentially. So I put it in the top, but technically it's like in the bottom or in the front. It really doesn't matter. Either way is fine. Okay, this is the last question I have, and I don't think I needed to do this for you, with you. I don't know. I think this one's not a with you. This is more like a for you, okay? Now, this is a lowercase k. A lot of times people make it look like a 12 or so. I don't know. All my letters look strange anyways. So I'm going to try really hard to make that look good. That's a lowercase k. And it says find DL, DV, go. So, and one other thing. M, N, and K are constants. Okay, so to do this, I'm going to have to do like the flagging method that one I showed you at the very beginning is way better here, okay? If you're going to do the little Newtonian, L prime business, it's just nuts. This is way better what I'm going to show you. But you don't even need me. I know it looks difficult, but do you see something about this? This is a nice moment to talk about this kind of problem and why I don't do every single problem on the homework. Do you notice something about this one? Here, I'll even do this. Hold on, right there. Okay, right there. No, okay. Can I just move a little bit? Okay, I was trying to make a point. Okay, there's no numbers. There's no numbers. There's no numbers, so there's no randomization either. That's it. So whatever answer you'll get it wrong a couple times. You'll see what the answer is. It's not a hard problem to get right. But I think that it has some merit to talk about because it is kind of different. So we got F, we got G. And what we're going to do is the F prime G plus F G prime. Okay, so that's my product rule formula for this. This will just go to 0 because it's a constant. So this whole thing is going to be 0. But how does that work? What is the derivative like of each one of these things? Like what's the derivative here? Well, here we go. So I'm going to take the derivative of this thing. Now, the m is a constant, so it goes to 0. What's my derivative of L? Oh, it's L prime. Hold on. It's DL. See how they're looking for these D's? You take the derivative of L. You get DL, okay? And then you leave the second one alone. Now you leave the first one alone. And what's the derivative of this thing? Again, n goes to 0. V goes to dv. Again, see how they're wanting that thingy? Instead of v prime, or instead of just saying it's a 1 or something, that is the method that you need to be using. So I want the dl dv, okay? That's my goal. What I'm going to do first is move this to the other side. You can choose either side, but I'm going to leave it pretty similar to what you're seeing here. Now on this side, it's a negative. I want, again, just what are you asking for? DL over DV. So they want DV in the bottom. They basically want to say divide this to the other side, like down here. And then I would just move this thing over here. So DL, DV, this is it right here. Negative in the top. You can go anywhere, but negative in the top. And then we have this thing that we moved over. And there's your answer. Again, you had no numbers. So you're not going to get a number answer here. We're done. We're done with that section. Thank you very much. Have a great day.